Hello, everyone. Welcome to this week's episode of ClueCon Weekly. Joining us this week is Wolfgang Kampichler, Principal Scientist at Frequentis AG and an expert in security and public safety. Thank you for joining us today, Wolfgang.
Yeah, thanks for having me. It's a great honor for me to speak on your podcast. I'm with Frequentis AG. And Frequentis AG is a leading provider of information and communication solutions for safety-critical applications worldwide. Our solutions are utilized in different domains, including air traffic management, airports, airlines, defense, public safety, public transport, and maritime. I think today we're going to talk a bit more about the public safety domain and actually, I'm with corporate research. It's a small unit at Frequentis, and my areas are real-time communication and standardization. So that actually brought me to NG 112 and 911. And I also support NINA and the European Standardization Institution, ETSI. I'm here in the MTEL group, and we have several standardization and interoperability testing projects, not only in Europe, but also in the US. And what I like about Frequentis is that I can also support some private initiatives like Tech 112. So that's an implementation in Austria where we providing a better accessibility service, which is actually based on NG standards.
Nice. So yeah, I have to say when I got your email and the intro from staff is I find it very interesting that we're talking about NG11 and 911 and the corresponding implementation in Europe. I'm saying that because even if I'm from Italy, I work with the US company. I've been working with the US company for a long time, and I'm very familiar with all of the enhanced safety features, especially because we are required by law to have them available on voice over IP lines. But that's for the US, for America. So I'm very curious what the state of that is in Europe and where it is getting implemented to.
Let's start with some European legislation. So we actually in 2018 there was application of the European Electronic Communications Code, which requires routing to the most appropriate PSAP, which is the emergency center in the US, and also to provide equivalent access for end users with disabilities to emergency services. So that's quite a long time ago. So now we have 2023, so 5 years ago. And there was also a change, let's say, in the regulation as well. So in 2022, there was some delegated act, some amendments, and we now are in the year of 2024. So next year there will be the European Accessibility Act measures to be applied. So this means that there needs to be network infrastructure, mostly I guess mobile network infrastructure, that supports this kind of accessibility. And if you talk about accessibility, this means IP-based or packet-switched. And this also means that you need some services that are specified in NG 911 and 112. So they are called NG core services. And since we have this, let's say, timelines for the next years, so 2025 in the networks, 2027 in the PSAPs, now PSAPs are going to look, or agencies are going to look into the technology, and we've already seen some call for tenders that are actually asking for this next generation emergency services standard. So basically, as I said, very important is route to the most appropriate PSAP, which means we need location information that we get from the end device that's being used to find out what's the most appropriate PSAP, which means not necessarily the one that is closest, but the one that has the resources, for instance, or that can answer specific calls with specific languages, or supports video for sign language, and so on and so forth. So we currently do not have it deployed, but there are countries that started projects and they're currently implementing it. And there's a small project in Austria. I mentioned at the beginning, it's Tech 112. So we have deployed this core services. so for the routing and then mapping to the most appropriate PSAP, and a very simplified text-based service that we provide better accessibility to Austrian emergency services. In Austria, it's like in Italy, you may remember. So we have several federal states, and we need to route to the federal state where the call or the chat is originating from, which means if you're in Vienna, it needs to be routed to a PSAP in Vienna, for instance. And if it's in Vorarlberg, then it needs to go to Vorarlberg. So even if Austria is a small country, it requires quite sophisticated routing and next generation being deployed.
So here's a question for you. I'm thinking about the so first of all, what enhanced 911 or enhanced 112 services are actually, for the audience might not know, is the fact that there is a location data associated with the phone number, so that emergency responders can automatically know where you are, or at least where your number is. Now with cell phones, that's a bit more complicated. That's where where it starts. The question is it a standard that's been implemented in Europe, or is the initiative currently private, or a mixture of the two?
It's a standard. So if you look at 3GPP specifications, so these are used for mobile network operator infrastructure and even for the end devices, or look at documents from GSMA, they are already describing how emergency communication with audio, video, and text works. So that's being standardized by 3GPP. What is still missing, or what needs to be implemented as well, is the next element, or the next thing in the core flow. So it's the kind of ESINet. It's an emergency services IP network that may interconnect several emergency services. And in order to route to the most appropriate PSAP, you need then this routing functionality. And since we get calls from a mobile network operator based on voice over LTE, it's already session initiation protocol. It contains location because it's standardized by 3GPP, how to provide location even from the end device using the location sensors, and or from the network if there is no location available for the end device. And then it gets routed to the PSAP. And the next element that needs to support these multimedia services is then the control room or the emergency services answering point or PSAP. So looking at all these domains or elements, you have the call originating service provider, which is the MNO. So here we have 3GPP specifications. Then we have, let's say, interconnected emergency services or PSAPs. Here we have the standards from ETSI and from NINA. And then we have the interface towards the control room or the PSAP itself. So all these three main elements need to support the same signaling protocol, need to support different types of media, need to support how to transport media, for instance. And those things are standardized in different organizations. So 3GPP for the mobile network operator, ETSI and NINA for the PSAP or the emergency communications part.
Yeah, that's really, I mean, it's truly very important, and I think people shouldn't underestimate how important it is. Well, the whole 911 effort in the US came from someone that was murdered in a hotel room, and there was no way to locate them before it was too late. It was a pretty famous case. So there is real safety built into knowing where you are and what's happening to you. I was taking a look at the DEC 112 website, and it looks really interesting. So if you give us more information about what that product is and how it works, that will be very, very interesting.
Yeah, that's actually the thing that started with a private initiative years ago. So when I started this standardization work with ETSI, supported by Frequentis, I figured out that, okay, we have quite a lot on the paper, but we do not have implementations. to just check if things that are on the paper or that are standardized can really be implemented. So I started together with some colleagues to implement the main features. And then it happened that I met people from the Austrian regulator, and they were discussing about, okay, how can we make accessibility better in Austria? Because there was just an SMS service available. And so I said, yeah, we do have those standards. We have some first implementations of those core services. So actually, we can start this with a pilot. And now we have the pilot running as permanent service in Austria, supported by the Ministry of Interior. And it's actually an application. It's based on SIP over WebSockets, so it gets the location information. It has a chat user interface, and you select an emergency number, that the emergency numbers that are known in Austria, and then it starts sending a message to these core services and provides location information so that you can route to the most appropriate PSAP. And if it's connected to the PSAP and the application user can just exchange messages. So it's like WhatsApp or Signal, but you get connected to emergency services. And the application is free for use in Austria. And we have quite a lot of subscribers. I think it's currently at 30,000 subscribers, and we have also a nice statistics webpage that I think currently shows that we had 3,000 emergency communications that were really connected to the PSAP. We do a lot of other test messages that do not count as real emergency services.
And I see you also have a silent emergency call feature in the app, which I'm curious about. How does it work?
Yeah, it is just a predefined message, actually, that everyone can choose for certain purposes when just installing the app. And if you just press this button that says silent emergency call, it just automatically sends the predefined message to the police, and the police sees that as a silent emergency, which means that if they dispatch resources, the resources or the officers know, okay, we have to be very careful because there might be some difficult situation and someone needs help. So you know these domestic violence things, so it's quite difficult, but this was actually the idea to implement it also in the application.
Definitely. And what about the standard of keeping the information, the location information for each number up to date in the database? Is there an API or something we can currently use to do that? Because in the US, there's a centralized entity that gives you an API you can go to and say, okay, this number moved from California to Nevada because this person moved to Las Vegas. So now you need to know the numbers in a different place. Is there a similar registry in Europe? Is it coming? How is it organized?
I think you're referring to this MSEC thing, correct? It's Master Street address card. There's nothing similar like this. I think in Austria, it's like, or in Europe, it's like if you have a fixed service, and if you apply for this fixed service, you need to provide the address, and I think it's just the provider that knows about the address, and this can be accessed by emergency services, this information, but it's not a central thing. But in the future, it changes a little bit because you may have different means to get to the location information. For instance, with the mobile device, you have GPS. You can also check your location based on Wi-Fi signals. And if this is enabled, and for instance, with the app in Austria with DEC 112, we just use this to get the location, and then we provide this recent location information to the PSAP. So there's no need to query additional databases because you just get it from the end device. And the standards also cover this. So in 3GPP, if it's an emergency call, the end device provides the location, or the network operator in the IMS needs to get to the location information and just inserts it directly in the call setup. So it's called PDFLOW, Presence Information Data Format Location Object. So it's XML kind of thing, and this provides location, either as civic address or as geo information, like a circle or a polygon or a point. And in addition to that, the standard, getting back to your question, the standard has something like a location information service or location service, which is kind of the equivalent to the MSEC database. So this is a central server that knows about location information, and this can be queried using a specific protocol. It's called HTTP-enabled location delivery protocol. So it's HTTP-based, and that's actually the API. And as far as I know, there are some of these providers in the US that already expose this kind of standardized interface. And recently in Austria, Frequentis started a project together with the Ministry of Interior to provide such a location service in Austria, because there are different mobile network operators, and currently there is no standardized interface that each of the PSAPs can use in order to get the location information. So for instance, if the end device doesn't support voice over LTE, we have this advanced mobile location in place called AML, which is an SMS that's being sent to a central point. And this central point stores the SMS, the number, and the SMS which contains location information. This then can be accessed via this held API from a PSAP. So I think that's more or less the future replacement or the current replacement of the MSEC.
So if I understand correctly, the difference is that in the US, there is a centralized database that law enforcement accesses via the phone number. So you call 911, your phone number is plugged into this database, which returns location information to law enforcement, while the European standard is to send the information through a separate channel every time the call is submitted or the message is sent. So there is no central list of phone numbers that says this number is in Milan, Italy, or Vienna, Austria. But instead, when you're calling, the location information is transmitted together with the call.
The example that I mentioned before is based on mobile devices. So if you have a fixed service, so if you have fixed line service, then your number is actually known by the mobile by the telco operator, and then the address as well. So if there is a need to get that location information, you have some databases. I think they're commercial available. Even I could just look up in the internet a number of a fixed access, and find out who that person is and which location it has. So I would have to pay for that, but I think for the emergency services, that's free. But it's not a single central service. And back to the US, I think if you look at mobile network operators, we will also see this kind of standardized location service in place. We've already tested this several times with mobile network operators and additional service providers to get the location in the same way. So it's very important to understand that there's no European specific standard and no US specific standard. So all the elements that are specified in this domain are the same. And we did already some interoperability testing transatlantic. So we connected implementations from European vendors with implementations from US vendors. And then we just checked if those interfaces are working. And we had some nice scenarios where calls were misrouted, providing a European location, but ending up on the US infrastructure. And then by interconnecting those infrastructures, we were able to route back to the right piece.
Yeah, that's of course there is that. It's not even a problem. Like that's the issue too, that the database based standard that the US uses doesn't cover any numbers that are not from the US or they're not set up properly. So while that greatly helps, it's not a full solution, because if you are, again, you're from California and you fly to New York and then something happens to you, your number is tagged as being in California. There's no way for anybody to know that you're not there. So I think more real-time approach is better. It's really
yes. And I think here the IMS and the voice over LTE calls or emergency communication helps, because that has location provided by the end device. So if you're just roaming into another country, the location is known by your device. And if the device also knows the emergency number, it will do an emergency setup with the network, and then there will be a local breakout to the local emergency service, and they will actually receive location information based on the same standard. So no matter where you are, so the US or in Europe, the end device can provide a location to the PSAP, and they will dispatch resources. Yeah. But still takes some time to get that deployed everywhere.
Yeah, so I think that's a good follow-up question. How long do you think it will take for the standards to be truly approved and used and be out there in Europe? Because that's always the problem. Like, we're full of very good standards all over, but sometimes they just don't get anywhere. What do you think is the time frame to get this rolled out?
For Europe, it's quite easy. Just looking at the European Accessibility Act that I think was published in 2019, that requires that these accessibility measures, which means routing to the most appropriate PSAP, equivalent access for end users, which means multimedia, needs to be in place by 2027. So we still have, let's say, 3 years to go. As Frequentis, we've called for tenders that are actually asking for next generation 1 and 2.
Yeah, I think the good thing about Europe is that we're quick at making legislation, but we're also good at making companies implement the legislation. That's a big difference with the US. There's where the governments have much more power. So while it can be inconvenient and there's a lot of legislation, and sometimes they go overboard. Like right now, I think the European Parliament passed a 1,000-page document about artificial intelligence. I mean, that's a bit premature, maybe, but still means we'll be organized when the time. It's going to take time, but we're going to get there for sure.
Yes, and I think you need to find something that really works everywhere. Yeah, because your example, just traveling back from the US to Italy, you take your device. You're not changing your mobile device, so you can make calls. So that works, but it might be different for emergency services. And if you get this standard, and if this is harmonized throughout Europe and in the US and perhaps worldwide, then no matter where you are, you should be able to connect to the most appropriate piece of providing location and getting kind of multimedia service which supports accessibility. And perhaps this takes some time to get it standardized and then to get it implemented.
Good. Yeah. Well, then we'll see. So some countries are better than others. So I think Austria and Germany will get it before some others. But we'll see what happens.
Yeah, but actually, you have in the US a deployment of core services in California. So they already started to deploy those services. And I think before Christmas, I joined a webinar organized by INA, where the people from the US were introducing how real-time text works from a native dialer application in a US mobile network environment. And there are even 2 or 3 PSAPs in Texas that are already able to receive this kind of real-time text. And it's also based on next generation 911, 112 standards.
Well, I mean, that's hopefully that's going to be out there very soon. Again, let's remind the audience that these laws came from real life things that happened. Like people lost their lives over not being able to be located in time, over the call going to the wrong place. I think the original instance was something like the responders actually went to the wrong address, meaning that by the time they were to the right address, things so it's already gone over. So it's really a very, very important effort. And well, I mean, thank you first of all for being part of that effort, because there's a lot in there. So thank you. Cool. So I don't know, is there anything else you'd like to add about the topic? Something people should go look up? Of course, your website, which is www.dc112.at. We'll put a link in the website. Is there any other reference you'd like to give the audience or things to check out?
Yeah, perhaps you also check out www.frequentis.com. So that's the company I'm working at. And as I said at the beginning, the great thing with Frequentis is that I can actually do all those things in parallel. So I can support standardization, which is volunteer. So we are not getting paid for that. And I can also, start some private initiatives to have something deployed in Austria that not only connects to Frequentis control rooms, but to other control room vendors as well, which is great because of the standard. Yeah.
Good. So, well, again, Wolfgang Kampichler joined us today and is from Frequentis AG, and we talked about the security and public safety, mainly efforts around 112 and porting 911 to the European network. And Wolfgang, thank you for joining us today. It was very interesting to have you here. It's such an important topic, and we don't feature it often enough. So maybe we could do another practical session where we go over what the actual standard is and what the interaction should be for APIs, etc., so people can start getting ready. Since 2027 is not that far away in telephone land, right? It's we're not usually super fast. Let's say that. So
yes. Yeah, thanks for having me, and I'm happy to support or to join one or the other ClueCon Weekly to talk a little bit more about technology.
Let's do it. Perfect. Okay, so again, Wolfgang, thank you very much for joining us today. For the rest of the people, I'll see you next week. Goodbye.